Okay, so the first thing that you'll see when you boot the visualization is the first screen. At the top left, there's a link to the nature dataset that we chose and based our visualization on. That way the user has easy access to the dataset that is actually looking at. Secondly, there's a subject selection screen, which allows the user to filter the subjects using two fields, so the biological sex and the age of the subject. There's two selection buttons and a slider that you can adapt to select a range or a single age even if you want to. But when you change these filters, the subject list is filtered accordingly. Say, for example, we want to look at subject 8, who is a male and is 26 years old. We can select them and click the Start Analysis button. At that point, the visualization will be loading because the dataset is quite large. There's 7.1 gigabytes of data, and even if we only select a single subject, it can take a while to load all the data for that subject. We tried our best to optimize this as much as possible, and as you can see, it does not take that long. When you reach the second screen, the first thing that you'll see is the two EEG and MEG plots. They are vertically aligned and share the same x-axis. You can scroll on these plots. If you select the zoom tool, you can zoom out, and the zoom is geometrically aligned, so it will zoom where your cursor is placed. At the same time, you can still scroll. Say we scroll all the way to the right, because in the runs of these data sets, they usually start with some a period of time where nothing happens, but at some point, mostly around the 150 or 200 second mark, the events will start occurring, and we, as you can see here, we denote these events using shaded areas, which are color-coded with the buttons up here. Another color coding that we also use are the buttons here, which are linked with the time series lines in both plots, as well as the 3D electrode/sensor location plots. When you select or unselect these buttons, the lines will the lines here will hide or be unhidden. The same with the electrode locations here, they will be highlighted or unhighlighted. And this can be done separately because at some point it might be that, you want to look at different signals for the different modalities. At any point in time, you can choose to plot the PSD. So when you set the power spectral density, when you click this button, it will take a while to calculate them, and you'll get the two power spectral density plots. Here we do plot the single electrode lines because it might be that you want to, because if you would average these power spectral densities, theoretically those calculations wouldn't be correct. However, we discussed a lot about this, and you can't really distinguish between separate lines, but that's not really what you're looking for here. You really just want to get a general overview of where the peaks are. So for example, here in the MEG plot, you can see that there's a lot of activity in the 0 to 10 hertz range, and the same between the 45 and 50 hertz range. That's what you're really looking at. The individual peaks are not that important. Again, you can select or deselect certain signals, and the plots will be updated accordingly. At any point in time, you can go back to the overview. So a side note, this view is really for the neurology researchers to get a general overview of what's happening in a complete run. This is also why we downsampled this to 45 hertz, which is a bit lower than what the other plots use. Because otherwise, if we would plot all the 5 groups at the same time, this panning action would not be that smooth. But as mentioned in the report as well as in the presentation, the human eye cannot really distinguish between these sampling rates, so this should be fine for the overview. At any point, you can also choose to view another run. So say we want to see run 6 of this subject, it'll take a while and you'll get the next run. Also important to note is that we show the subjects that we selected in the first screen up here. We don't want the user to have to remember which subject is selected in the first screen, and that's why we find it important to plot it, to show it there. Then perhaps one of the most important parts of our visualization is calculating the average window. And for that I'll go back to where the events are happening. So in these data sets, the subjects were asked to look at certain pictures of famous, scrambled, and unfamiliar faces. And so neurology researchers will really want to know what's happening at those points in time. And that's why they will often calculate an average window. So around the types of these, the time offsets of these events, they will calculate an average window starting a certain time before the event, which you can select here. Say we want 1 second, 1 second before the event happened, and 1 second after that event happened. If you then also select one of the events that you want to average around, say for example, we'll look at what happens when they look at famous faces, so pictures of famous faces. These are the blue shaded areas on the plots. If we then click the average button, an average window will be calculated around each of the famous events. At this point, it'll calculate, might take a while, but again, large data set. And then you'll get the average window here. And this is what is really important for the neurology researchers, because here they can really get to see what is happening when these subjects are looking at these types of pictures. They can deselect certain lobes, okay, so they see that the blue one has quite a high peak. They know that it's the parietal lobe. They have a 3D plot here to make them remember where that lobe is actually situated. They can also compare to the MEG plots. Say you select the parietal lobe here, you can see that there's no peak here, so that's already a difference that they can learn using this visualization, that perhaps the parietal lobe does not peak on an MEG when people look at famous pictures. On the other hand, for EEG there is a peak, and so on. For these average windows, which is also interesting, you can also calculate the power spectral densities. And so say we now again focus on the parietal lobe and deselect all the other ones, we can see that those peaks in the EEG plots mostly happen between 0 and 10 Hertz. And that way the neurology researchers can link this type of activity, which they know is happening because they saw peaks in this plot. They can link it to the certain frequency ranges, which will then tell them what type of neural activity is happening in that lobe. And they can do that for several lobes at the same time. They can compare lobes and so on. And that's really it for the average view. At any point in time, you can also go back to the complete runs. You can select other events to average over. You can even select all of the events, and that way your average window will not necessarily say something about which type of picture they're looking at, but more will give more a general view of what happens when those people are looking at pictures of faces in general. At any point in time, you can also go back to the first screen by clicking the Change Subject button, and then you'll be able to select another subject if you want to. And that's it for this demonstration.